So please don't forget to like our videos, share, and also subscribe to our channels. So today we'll be talking about number system. We have number system is just like series of numbers that we have in mathematics because there are many like that. So in this video, I'll be telling you how to differentiate each numbers, even as well how to classify when we have like prime numbers, when we have like even numbers or odd numbers. What do you mean by that? So the first one we'll be talking about is a natural number. Natural number. So when we have a natural number, what do you mean by natural number? Natural number simply means the counting of whole number, the counting of numbers, the number that we have in mathematics, like 1, 2, 3. You understand? So let's just write down. You can see natural number is the counting of numbers or whole numbers. So that's what I mean. Whole numbers. It's denoted by capital N. If you see N, you know that they're talking about natural numbers. So this part is one of the major part that we have under the number system. So natural numbers, the counting of whole number, like 1. Let me give you an example of that. Like short about this. Okay, just refill this one. Sorry about that. So like 1 e.g. like 1, 2, 3, 4, 5, like that. All those numbers that we have, we call it a natural number. You can see under natural number, we don't have negative. It started from 1 upward like that. You understand? So like it has some property that we need to take note, and it's also denoted by N. Whenever you see N, capital N simply represents natural number. So it has some properties that we need to talk about. So it can be in form of prime numbers. Let me explain that one too as well. This natural number can be a prime numbers, it can be even numbers, it can be odd numbers as well. You know, when I say prime number, what does that mean? Do you remember? You know, when we are in secondary school, they taught us what we call prime number. What is prime number? You know, prime numbers are those numbers that cannot be divided by any other number except 1 and itself. And when we have even numbers are those numbers that can be divided by 2. And we have what we call the odd numbers. It's all those numbers that cannot be divided by 2. So this prime number can be any of these. You know, when I put 1 here, I'm referring to odd numbers. Put 2, it can be even, it can be prime. 3 is also the prime numbers or odd numbers, like that. So we have some properties of these natural numbers that we need to talk about. Properties of natural numbers. Property of natural numbers. So one of the properties that we're talking about here, we call it just like it's closed under additions. What does that mean? Let's say I have 2 natural numbers. Let's say I have M and N to be natural numbers. So they say it's closed under addition, meaning if I add them together, I will still have another natural number. That is, if you take 2 natural numbers and you add them together, you are still going to have another natural number. Meaning, if I have this M and N to be a natural, if you see the symbol, it's element of natural number. Meaning, if they belong to a natural number, that is, if I add them together, I will still get another natural number. You can take any natural number of your choice. Let's take for example, let's say if M equal to 5 and we take our N to be 6, for example, you can see M is a natural number. At the same time, 6 2 is also a natural number. So let's test if you add them together. Can we have another natural numbers? If I add them together, 5 plus 6, you can see is 11. And of course, this 11 too is also a natural number. That is, this natural number is closed under what? Under addition. The second one too, we have what we call commutative law. That is addition and multiplication of natural numbers are commutative. What does that mean? Commutative commutative. Meaning, if I have two natural numbers, either I had them by right to the left or left to the right, I will have the same. Let's say, for example, let's say for m and n to be a natural number, this means m plus n must be equal to n plus m. That is, if I say m plus n, will definitely be the same. And if I have n plus m for any natural number of your choice, you can pick any. Maybe we should pick another one. Let's say if m equal to 1, I will pick n to be 3. So let's look at this side. M plus n must be equal to n plus m. So if I take m is 1. If I take n is 3. If I take n is 3, then m is 1. So 1 plus 3, we have 4 here, and now we have 4 here. You can see this natural number is a close under addition for commutative. Even if it is multiplication as well, let's say I want to have mn must be equal to nm. So my m is 1 multiplied by 3, which is the same thing as 3 times 1. So 1 times 3, we have 3, and 3 times 1 also we also have 3. That means it's close under addition and multiplication of natural numbers are highly what? Commutative. So another property that we have also here, we also have associative, that is either under addition and under multiplications. So take a look at that. So let's take a look at that. Let's say I have said multiplication 3, addition and multiplication of natural numbers are associative. Either be in form of additions or either be in form of multiplications. So 5, we have 3 natural numbers. Of course, they will satisfy the condition of a natural number. Let's say, for example, let's say we have m, n, and p to be a natural number. So meaning, if I have m plus n plus p, this is the same as if you firstly add n and p together. For any natural number that we have, meaning it's close under addition and multiplication for under associative. Let's say, for example, let's say if you pick any natural number, let's say we pick m to be 1, we pick n to be 2, and we pick our p to be 3. So if I want to substitute the condition of the 1 we have at the left hand side here, so my m is 1, I have 1 plus, so my n is 2, I have 2 plus our p is 3. We said it will be the same as if we first have n here, our m is 1 plus our n is 2 and our p is 3. So here I can have 1 plus 2. That's going to give us 3 plus 3 here, 1 plus 2 plus 3 here, we have 5. So that means, of course, if I have 3 plus 3, we are going to have 6. 1 plus 5 as well, we are going to have 6. So on the addition and multiplication of natural numbers are totally what? Associative. So we also have another one. We also have another one. All those properties, you just have to know them. We have multiplication of natural number is right-left distributive. Multiplication I'm almost done. No. I'm going somewhere by one. Is he going somewhere?
No.
I'm not going anywhere. So what are you now looking for? So multiplication. Hope I can continue, sir. Can I continue?
Yes, you can
continue. Okay, so thank you, sir. So multiplication of natural numbers is right. Is left distributive. Let's also talk about that one. Right, either right. Maybe I should just discuss the two at the same time. Right and left distributive. So that to save our time, what do you mean by left distributive? Let's say I have 3 natural numbers. Let's say we have n, p plus q to be where n, p, q are element of natural numbers. So this is, if you look at n, we have here just how to distribute n for p. This is left. But if I have like this is right? Exactly. So either left or right is totally distributive. Can we check? Any natural number of your choice. Let's say maybe we have n to be 1, p to be 2, and q to be 3. If I put it here, my n is 1, and we have 1, bracket of our p is 2, and our q is 3. So here we have 2 plus 3, we are going to have a 5. Then 1 times 5, we are going to have a 5. So here too, if I use this one as well, it's still the same thing. My p is 2, and q is 3, and our n is 1. So 2 plus 3, and we have 5 of 1, and of course, that's going to be 5. That means multiplication of natural number is right and left distributive. Then another one we have what we call law of trichotomy. If you see the term is somehow trichotomy. Don't mind them. It's still just like a term that we normally use in mathematics. Let me just explain that. Law of trichotomy. Law of another property. Law of trichotomy. Trichotomy. Meaning, let's say if m and n are elements of natural numbers, one of the following holds. One of the following holds. Meaning one of them must satisfy. Is either we have m greater than n, or we have m is equal to n, or n greater than m. This one was trying to tell us that if I pick any natural numbers of my choice, if I pick two natural numbers, let's say I have picked any number for me, you can pick any one of your choice, even different from the one I want to use to text this law of trichotomy. Let's say I pick my m to be 10, for example, and I pick my n to be 4. You can see, if I want to check that which one holds in this 3 now, because of course we know that this m is bigger than n, meaning the first one holds here, m greater than n. So of course, but if I check, let's say I have m to be 10, and I also have my n to be 10 as well. So meaning the m and n are the same. Of course, the second one we also hold. Or let's say I take my n to be 15, and I take my m to be 1. That means the third one we hold. So far we have two natural numbers. We have what we call law of trichotomy. These three must hold. It's either m greater than n, meaning either the first one greater than the second one, or the second one less than the first one, or the two are the same. The only condition that can make the two to be equal is when the value of m and the value of n are the same. Or we can have n to be greater than m, meaning, let's say for example, we take m to be 15 and we take our m to be 1, meaning the third one we hold. So when we have the law of trichotomy, we are talking about these three expressions. Either the first one greater than the second one, or the second one greater than the first one, or the two of them are equal. So the last law we are going to discuss under these natural numbers, we have what we call cancellation over, or let's just talk about that because that one is also similar to this. We have cancellation law of addition and multiplication. Then as well, we have when we have two natural numbers, meaning, let's say I have two natural numbers. Let's say let's use another one. Let's say m and n, for example. You know, if the two of them doesn't have the same value, m plus n can never be equal to m. They can only be equal, it can never be equal. Even if the value of m and n are the same, they can never be equal. How? Let's take a look at, let's say if m equal to 1 and n is equal to 1. So let's add them if they are going to satisfy their conditions. That's m plus n, meaning we have 1 plus 1, 2. You can see this 2 is not equal to m. Either the two of them have the same value, so 5, they are natural numbers, either they have the same value. For example, let's take m to be 4, and let's take n to be 6. If I add them, m plus n, that's going to be 4 plus 6. You can see, so 4 plus 6 here, of course, we are going to have 10, which is not equal to either m, and which is not equal to n as well. So if I pick two natural numbers, either they have the same value, either they have different values. If I add them together, that result can never be equal to any of the two because it's a natural what? It's a natural numbers.